Hey robot makers, do you want to learn how to make a capacitive touch chicken nugget piano using CircuitPython, 13 chicken nuggets and a Raspberry Pi Pico? Then this is the show for you. Let's dive straight in. My name's Kevin. Come with me as we build robots and projects, bring them to life with code and have a whole load of fun along the way. Right, let's get straight to this one, shall we? So yes, this is all about how to build a rather greasy chicken nugget piano. So let's get into this. We can talk about the why later on, I think. Let's just talk about the how for now. So before we start this, what is capacitance? You might have heard of capacitance before. Let's have a bit of a dive into see what this is all about. So it's the ability of a body to store an electrical charge. A capacitor usually consists of two conductors separated by an insulator, a dielectric. And the amount of charge that's stored depends on the size of the conductors, the distance between them, and the dielectric material. So you might have used capacitors in some of your projects. Some of the boards that you use may well have capacitors on them. And we're going to build one using ourselves as the kind of dielectric. So we're going to see how this works. So, capacitive touch, how does capacitive touch work? So your body's going to be the conductor. When you touch a capacitive sensor, which is simply just a GPIO pin with one single resistor on it, that's going to alter the capacitance of that sensor. And the change of that capacitance can be detected through the circuits, the sensor's circuitry. What we're actually going to do is do something really quite clever. We're going to set a pin high and then we're going to switch that over to be a read pin, and we're going to read in to see what the capacitance is and how that changes. And we can measure that discharge of the capacitor over time, a very brief amount of time, to detect that capacitance change, and that will allow us to detect touch. It's really quite effective, it's quite magical and very, very simple and cheap to do. So the touch sensor forms a capacitor. So for this we just need something such as a, I've used some aluminium foil for this. Just trying to see if I've got rid of that piece. I think I have. Oh no, there it is. So I've just got some kitchen foil, which is just aluminium foil, and I've glued a little piece of paper that I printed out, which I think I've now thrown as well, and that had a little picture of a keyboard on it just so I could see what the size of the keys were. And for this particular one I created a little keyboard that I could experiment on, and then I went on, as you'll see in the demo slightly later on, to some chicken nuggets instead of that piece of aluminium. You can use anything that can conduct electricity. Fruits, vegetables, things like that, anything that's organic tends to be able to conduct electricity, and we can detect that capacitance change when you touch it. So for this we simply just need the Raspberry Pi Pico. So I've got a Raspberry Pi Pico on a breadboard just here ready to go. This is just a Raspberry Pi Pico H. That's the one that's got the header pins on it, and it's simply just pushed into a breadboard ready for us to start connecting some things to it. We also need a 1 meg resistor. So I've got one just here. If I can hold that up and you can see it, it's a tiny little resistor. So that's 1 mega ohm, a million ohms. We're going to use that. That's going to sort of slow down the discharge so that we can actually measure it. And we simply just need to put that kind of in line with the pin that we're going to connect to our touchpad, which is just the aluminium foil for now. We can actually just use a regular piece of wire to detect the touch. You'll see when we do some experiments how that capacitance can change, and we can simply just set a threshold, and so if it's below that threshold it's not a touch. If it's above that threshold we can consider it to be a touch. So the Raspberry Pi Pico will measure that time that it takes for that capacitor to discharge. So we'll get into the building one live on the stream in a second. It's such fun to do this. So the code for this is pretty straightforward. We're going to first of all set a GPIO pin as an output, and this will charge the capacitor by setting it to high. So it's actually going to send 1 volt out of that, 3.3 volts out of the GPIO pin. That resistor is going to be also going to ground, so that's going to take away some of that voltage, if you like. And then we're going to put in between where the ground and the Pico pin is, we're going to put a jumper wire, and that's what we're going to touch to begin with to do our experiments. So the GPIO then will then switch from an output to an input. We can then measure the time it takes for that voltage to drop, to discharge. And that discharge, we can use the TIX US and the TIX diff to measure the difference in time in microseconds. So it happens real fast, but because the Pico is even faster, we can measure this. So it's a very, very simple piece of code. We'll walk through it step by step when we do the demo in a second, which is not far away. So detecting the touch, if the discharge time is greater than a threshold that we will set, the sensor can be considered to be touched. The code will check to see if that sensor is touched or released, and then we can simply return a 0 or a 1 or a touched or not touched string if we want to do it that way instead. So this is the output from a little program that we're going to run in a second. You'll see there we've got some touched statuses. You can see there's a time, and that's how long it takes for that to discharge. So it's somewhere between 173, 76 there and like 617. So it's quite a wide range. But when it's not touched, it's like an order of magnitude smaller. So it's like, what's the minimum we've got there? 38. I think 38 is the smallest one, up to like 40, 43, I think, 47. There you go. So it's really much smaller. So we can see that there's a definite difference between the two. So let's illustrate that a little bit better on a sort of larger size here. So we can see that the area where it's touched, that's where the sort of spikes are quite high, and where it's very flat, we can see that's where it's not touched, and we can draw a line and say that's the threshold. And that value on there would be like 150, for example. Anything above that's touched, anything below that not touched. So that's how we can make our code return what the status of our touch sensor is. Very straightforward. So what kind of applications can we use for this? Your smartphone has a touch screen on it that uses capacitive touch as well. The capacitive sensors are behind the screen. Sometimes they are a layer on top of the screen with a very fine mesh. Resistance touch is the kind of opposite of that, so that measures the actual resistance. Capacitive touch is generally a lot more friendly and easier to work with. We can also use them for plant soil humidity sensors. So in the Pimoroni Grow Kit, which I've got behind me growing some chilies at the moment, that uses capacitive touch sensors, so they can measure the soil humidity, and because they can be covered in plastic, they won't rot in the same way that the cheaper resistance touch ones do, because they have, oops, let me just move that off there, sorry, because they have, let me just set that to do not disturb, sorry, it usually sets this to do not disturb. It doesn't bring up any messages on my screen, sorry about that. So yes, if you use the resistive touch ones, they tend to be just like two pieces of copper, and they will corrode over time as the moisture in the soil edits it. So could you use plushies for this? Ford says they're not really made of organic materials, so if they had something on them that conducts electricity, then you probably could, but the best way is to try and experiment and see what works and what doesn't work. And because it's measured in microseconds, the response rate is ridiculously quick. There's no lag at all between you pressing it and you getting the response back. So really useful. And we can do things like create Midi controllers. We can create our own piano. We can create a game controller with this if we wanted to. Have seen people playing Minecraft, touching a banana to move forward and an apple to move left and all that kind of stuff. So all kinds of cool stuff. We can build proximity sensors, level sensors, all kinds of things, buttons and sliders as well. So I thought we'd use something a bit more crazy today, chicken nuggets. Why not? So if you like what I do and you want me to make more kinds of videos like this, please make sure you drop this video a like. See, we've got 3 likes on the video at the moment. Drop me a comment, let me know what you would use a capacitive touch sensor for, and whether you want to build one for one of your projects. And if you've not subscribed to the channel, please subscribe. It means so much to me every time people subscribe to the channel. It costs you absolutely nothing to do that. And I do go live every single Sunday at 7 o'clock GMT or BST, depending what time of the year we're on, so you can come and join the party live and hang out and have a chat. Okay, so how to make a capacitive touch sensor. So we're going to do this live on the show in a second. So first of all, we need some kind of microcontroller. You can actually use like an Arduino or like an ESP32 or 8266, whatever. Anything that has a GPIO pin, basically, that can switch between reading that in. Anything that can run MicroPython can do this, essentially. So we're going to use this Raspberry Pi Pico that I've got here, which is just the original version that's got the header pins on it. We need some crocodile clips, so I have a bunch of crocodile clips. Just to show you them to make sure that we're all on the same page with what these are. So these are crocodile clips. Does it look a little crocodile? And we need some jumper cables. So I've got 2 jumper cables. I've got sort of a long white one and a small black one. So these just have these little pins on the end already, and they're designed for just sort of going into breadboards like so. So we can just poke these in, poke these to different places, and so on. So that's what we're going to be using. And of course we also need to have that 1 meg resistor as well. So I'll show you these as we put them into the board in a second. And you need something to touch, so you can experiment yourself. Like I said, I created this little keyboard to begin with. So which way around does that go? That goes that way up. I think I actually got this back to front. I think I printed it and then flipped it. So if you think the C is there, C, D, E, and then F, G. Why did my brain go blank then? A and B. So yes, you can create this however you like. Anything that you can connect a crocodile clip to, you can do this. I've included on the website for the build for this a PDF, so if you wanted to download that, you can download. It actually flipped the correct way around, so you can print that out and make your own. So I simply just printed out the sheet, glued the sheet with some glue pen to the back, and then I cut out each of the keys and then glued them to the cardboard, or I think I used basswood that I'd laser cut and coloured in just so I could see where the keys are supposed to go and get them kind of straight-ish. Still looks a bit silly on there. Okay, so that's how we can make one of those. Let's do this now live on the stream. So I'm going to go over to the overhead camera, and I'm going to try and show you this and build it one step at a time. So first thing we need to do is get our Pico. I'm going to use a GPIO pin 1, which is at the very top there. So I've got my resistor. I'm going to try and do this and show you at the same time. So I'm going to put it to the very edge of the pin there, and then I'm also going to put it into the negative rail on our breadboard. That feels about right. So can you see that there? So from GPIO pin 1, or pin 0 I think actually at the very top there, and then that's going into this negative rail. So we need to connect that negative rail to a ground on our Pico, so the third up from the bottom. That'll do nicely. So that's now connected up the ground to our resistor, our 1 meg resistor, and I'm simply going to get another cable, and then there's a little pinhole just next to that we can use like so. So that's all the wiring we need to do to begin with. So what I'm going to do now is just connect up the USB cable for this. Let me just find that, and then we can go over to the code and start programming this. So let's just plug that in like so, and I'm just going to leave that dangling there for a second, and let's go now back over to, let's go to this view over here, and let's load up Thonny, and I'll show you Thonny first of all. So I've got some code over here. Let's go for Pico Touch to begin with. Sorry, sometimes it does that when you double click on the title bar. So Pico Touch. So this is a very simple piece of code. We're going to use this touch library that I've created here. We can have a look what this looks like. So we import from machine the pin, we import from time the sleep US, ticks US, and ticks difference. So these are all measured in microseconds, so they're very, very, very quick. We've then created this class called touch. We're going to initialize it, so whatever pin number we provide in, that will be set for this particular class. We can then provide a threshold value. I've just provided 130 as just as an example. We've got this sample here as well. You can just leave that as the default. So it's just going to set up some internal things and just set is touch to false to begin with. We can then measure the touch. So this is where we do the measuring the discharge and averaging it for stability. So we can say total time equals 0. And then however many samples that we pass in, I think it was 15 to begin, 5 to begin with, it'll just read in the values a couple of times to average them to get a nice stable reading on that. So the first thing we do is we set the pin to out. We then set the value to 1. We can then sleep for 10 microseconds. We can then set it to a pin in, and we can then read the ticks US time. And then while it's still 1, we basically just go around and loop past does nothing. And then when that's finished, we can then say end time equals ticks US. So we've got a start time and an end time. We can then say total time equals the ticks difference between the end time and the start time. And we use this ticks difference rather than just taking end time and start time. because that can handle the wraparound. So it's a bit like a mileometer on a car, where when it gets to like 999 it rolls back over to 000, and it's the same with time frequencies on microcontrollers. So they can get to a certain value and then go back to 0. So using tick diff, you get the correct number there. We then sleep for like a tenth of a second or 100 microseconds. We then return the total time divided by the number of samples that we've provided, and that will give us the correct number of discharge microseconds that we've read. We then got is pressed, so if the discharge time equals, we set the discharge time to equal measure.touch. If it is touched and that's less than the threshold, then we can say it is touched. That threshold we set earlier on, I think there was 130 there. We can change that to be whatever we want. Is released, we can see if it's not pressed. We can get the value for what the current value is, otherwise return nothing. We can get the touch status, and it'll return touched or not touched as a text string instead. And we can get the touch value, and that's just like a 1 or a 0. So very, very simple to get that touch up and running. So if I just do stop on there, that'll reset our MicroPython. I'm using MicroPython 1.24.1 on here. We just need to make sure that that touch is uploaded. I can see that it's on there, but let's just do that for the fullness of the project here. And then we can go back to that Pico touch program and we can start running that. So if I now run that and I go to this kind of split screen view, you can see at the bottom there that we have these readings. The other thing we can do, just going back to the full screen for a second, is we can go to the plotter. So if we go to plotter, we'll also get that nice little reading at the side as well. So let's go back to here. Now if I touch this this pin, you'll see there that it's now, we're getting kind of some wildish values, but if I let go, you can see there it drops down. So there's a definite touched and not touched, touched and not touched. You can see on that little plotter there, touched, not touched. So that's really quite effective. Now we can continue this experiment. Let's add in some crocodile clips. So I've got some crocodile clips. I'm simply going to clip these to the end of this pin. Now when I do this, watch the time. I think it does actually go up a little bit because this cable is also adding a bit of capacitance to the circuitry. So it's still underneath our threshold of 130. And if I now press these and just touch the metal bit, you can see there we've got touched, not touched again. But now we can add something like our keyboard. So if I add this to here, we can now see that if I now press that key, we are now getting a reading coming through, touched and not touched. Right, let me go back to the full screen for a second on here. So I'm just going to stop that from running. Now MicroPython is great as a starter in this kind of project, but if we want to do anything with Midi, which is the musical instrument device interface, and that's what that stands for, we need a Midi library. And there aren't many Midi libraries that I'm aware of for MicroPython. I think I might have developed one myself a while back, but we can really do this a lot quicker and easier if we use CircuitPython. So what I'm going to do is I'm going to install CircuitPython on our MicroPython device. So let's just, I'm just going to move that plotter off there so we can see here. And I'm going to show you how you can reboot, instead of having to pull the power, hold down the boot button and then plug the cable back in. There's another workaround you can do on MicroPython. So if we say import machine, and then we do machine.bootloader, loader like this, it'll then disconnect and it's actually ready, it's in bootloader mode. So if I now go down to the bottom of the screen here, click on this little MicroPython thing, I can say install CircuitPython. I'm on a Raspberry Pi Pico H, and we can just say install. So it'll very quickly now install CircuitPython on our MicroPython device at the moment, and that means we can use the Adafruit MIDI libraries much easier than writing these ourselves. They're quite tested, they're quite mature libraries these, so they just work. Just take a little couple of seconds for CircuitPython to get installed there. And it has got some differences as well. So CircuitPython actually shows up as a drive on your machine rather than you having to connect to it with some special software like Thonny. So if I click stop there, if I click stop on there, we can see we've now got some extra files. We've got a lib folder there, and currently we've got this Adafruit MIDI library in there, but only because I've copied that. So I'm going to just show you, if we go to the downloads folder, I've actually downloaded the Adafruit CircuitPython 9 library. So they've got a library that's got all kinds of sub-libraries in it, so they don't install everything, you just pick the ones that you actually want on there. We can see they've got Adafruit MIDI, so if I grab that and I drag that, in fact I can drag that, let me drag that actually onto the CircuitPython drive itself. So if I go to that, drag that across to the CircuitPython drive, we can see here that this is now starting to copy that across there. And we don't want that to be in the root, we want that to be in the lib folder. So once that's finished copying, we can just drag that across there. So we just drag that onto that lib folder. Let's just replace that one that's already there. We've now got the Adafruit MIDI library now installed on our device. There's quite a few things in there. We don't need to worry about them. We can now go to our code. So if I go back over here and just do a refresh, just to make sure everything's there. Cool. And what we can do now is we can go over to the MIDI threshold program. So this is the code that comes with this particular project that I've been creating. So let's have a quick look through what this code does. So we're bringing in a whole bunch of things. So CircuitPython is a little bit different than MicroPython. Instead of having machine, you have board. We've got Touch I/O, which is a library all about touch interfaces. We've got Digital I/O, USB MIDI, Adafruit MIDI, and then we've got these note on, note off functions that we're bringing in as well. So we then want to define a whole bunch of GPIO pins that we can potentially use. This one I think has like 26, 28, so all the possible pins that you could possibly use on our Pico. We've then got this little array of touch sensors, and for each pin that we're going to pass in those touch pins there, it'll then set up a touch I/O pin for that. So that's going to do everything that we've done in our own little touch library, but it's a bit more mature with some error checking in there as well. We've then got some baseline values, so this enables us to dynamically determine what the threshold value is. So rather than us hard coding in 130, we can actually get it to do this itself every time you switch it on. So depending on what you've got plugged in there, it can figure that out just by looking to see what the baseline average is, and then we can then figure out what we want that threshold to be. So this one's got like a baseline plus 1000. We can then set up our MIDI device. So I've got this plugged in to my Mac. My Mac has got GarageBand installed on it. So GarageBand, if I just put this over here, let's see if I can hear this. Let me know if you can hear that. So that's we can even use the musical typing keyboard if we wanted to do that as well. So this is just a MIDI program, and this will detect any MIDI devices plugged into it. So we can use this to hear the outputs of our MicroPython MIDI program. So what we've got then is we've got a whole bunch of MIDI notes. So 36 is sort of middle C, 38 is D, and so on. Or 38 may be C sharp, perhaps. I'm not sure. We've got a whole bunch of notes anyway on there. And then we're going to basically set all the notes to be false, so we're not touching any of the pins to begin with. We can even use the LED on the Pico itself to flash or to go on whenever a key is pressed. We've got that visual feedback to see that our touches are actually working correctly. And then we can set the LED direction to be an output, just because it's a pin like any other. We can set whether it's an input or an output. We then print out what the baseline touch thresholds and release thresholds are. And then we've got a little loop that will test to see, is a note being held down? If it is, play that note through the MIDI output. If not, release that MIDI note, and also turn the LED off and set that note played to false. So this will go around sort of ad infinitum. So if I now hit play on here, and I get my little keyboard, I'm just going to get this to be like so. Let's press play. So this is now starting. If I now hit that first key, can you hear that note being played? If we go to our GarageBand, you can see that that note is being played there. So we could even hit record, and we can see that we have some notes recorded there. So there we go. We can even look at the musical score for that magnificent piece of music I just created. So that is with a single key. Okay, let's move this up a gear. So what I'm also going to do is just show you, just on the overhead screen, when we hit that key. Let's just get this so you can actually see what's going on. So when I press that key, you'll see that the LED on the right next to the USB cable there, that sort of lights up as I hit that. Now you can sometimes hear that it seems to be pressing multiple times very, very quickly, and that's to do with the thresholds. We need to sort of dial that down a little bit, I suspect. So what I'm going to do now is just disconnect that that project, and then I'm going to reconnect the main project for this video. So let's just plug that in there, and you can see I've got on here a number of chicken nuggets, and each one is connected to essentially a different GPIO pin on this Pico that I've got over here. So what I do need to do is just restart that MIDI threshold program. So let's do that. It's reading all the default values because each nugget's a different shape. It's potentially got a very slightly different capacity kind of profile to it. So it's figured out what they all are, and therefore what the touch threshold should be for each of them. We may need to dial each of these slightly in differently depending on how this works or not. I've had some kind of hit and miss. It also might be to do with all the pins that I currently have shoved in with the little resistors. They're all very close together. If I did this as a sort of soldered PCB, it would work like a lot more reliably than this is going to work. But what you can see we've got there, so let's go back to our thing down here, and let's hit record. If we don't like the piano, we can even change up that that sound as well. We can go to we can even do like a drum kit if we wanted to. Let's go for this drum. Let's continue with that. Let's see if I've got that right. Let's try that one. Can't hear it actually making any sounds there. There we go. I'm just going to get it to restart that MIDI because we changed it halfway through. Sometimes that can sort of mess up a little bit. Getting really greasy hand doing this. What I do for the love of projects. Right, let's go back over here and let's have a look at our drums. We can even change the reverb if we want a bit of extra reverb. And we go back. We can go to what's this? Percussion. No, can't hear anything on that one. We can go for a strings if we wanted a strings ensemble. I can't hear that. That must be too quiet. And we can also go back to the piano as well. So let's go back to that Steinway. And of course it is polyphonic. You can do two notes at the same time if you wish. And this is all basically just using that Adafruit MIDI library. So you can imagine you can create all kinds of projects with this. You might need to move around some of these resistors just so they're not touching and so that they're firmly in the breadboard. I think what might have happened with some of these keys that don't seem to work is that essentially just the resistor has come out slightly from the breadboard, and because they're all so tightly packed in, it's quite fiddly to get that right. So I was aware that this would happen. Also, how the nuggets are connected is simply they're just sort of pinching part of the skin. So when you make contact with it, you're completing the circuit. Don't think that one works. That's the next one that seems to work okay. There we go. Got like a really greasy hand now. So think about the kind of possibilities with this. You can make all kinds of things. You don't have to use food. You could just use regular pieces of metal. You could create a touch PCB. You could even create, wherever it's gone, this into a regular PCB with a Pico attached. So you could create your own Midi keyboard that's completely Pico powered. If anybody's interested in me creating that as a PCB, let me know in the comments and I will follow up on that one. It should be quite a trivial thing for us to do in KiCad or Fritzing or whatever circuit program that we wish to create a PCB on. Let me know and we'll look at creating one of those as well. Cool, let's jump back to our slides. So we've got a couple of products on the store now that you may or may not be aware of. So if you want to know which pinouts do what on your Raspberry Pi Pico, you can turn to, let's find the right page for it. So there we go, page 6 and 7 have got all the Pico pinouts that you could wish to know about. So you can see GPIO 0, GPIO 1 and so on. They're all listed nicely on the Robot Maker's Almanac, so you can get yourselves one of these from kezrobots.com. We also have a number of PCBs as well, so there's the gamepad that you've got there, you can see on screen. We've also got the Pico Tamachibi, which is that little virtual pet, as well as the servo helper, which is great for other kinds of projects that have servos. And of course we also have the Maker Notes, which are really great for putting all your little project ideas down. I'm sure I've got some chicken nuggets somewhere on here as a project idea that I sort of scribble down, but you can use these. They've also got nice little dots on, so you can create little circuit diagrams. They're sort of perfect for exactly that kind of thing. So you can grab them in packs of three different colours at kezrobots.com. It's my own sponsored section. You can also join us on Discord if you've got any questions. Rather than reaching out to me, as some people seem to insist on doing by email, I can't answer all the emails that I get in, unfortunately. I get lots and lots of them from different people asking very different questions. So the best place to ask those questions is actually in our Discord community. There's a whole bunch of really enthusiastic people over there. You can share your projects, where you're up to, the code, screenshots, or videos, anything like that. And it's a lot easier to do than trying to do this backwards and forwards using some kind of email. So definitely try that out instead. It's completely free. Just go to kezrobots.com/discord to get a sign up link and you'll be up and running in no time. And if you want to follow me on social media, I'm on all the social medias. So on Threads, I'm at KevMcAleer at threads.net. On TikTok, I'm at KevinMcAleer6. On Instagram, I'm at KevMcAleer. I'm on X at KevsMac. I'm also on Mastodon at kevsmac at mastodon.social, and I'm also on Blue Sky at kevsmac.bsky.social as well. And you get all kinds of behind the scenes previews of things I'm currently working on. You can interact with me on there as well. If you want to get your name in the end credits, you can do that a number of different ways. The easiest way is to go to kezrobots.com/coffee and you'll find all the instructions and everything that you need there. And you can get your name at the end credits, which is what we're going to do next for all the people who have supported me so far. So let's check out over here. We have all the people that have bought me a coffee, which actually... Did I update that? I think nobody's bought me a coffee in the past month, actually. Jojo was over a month ago. And then on the Buy Me a Coffee, we have Silicon Fiber, Marie TKD, we've got Andrew, Shemi, Jeff, Dien Corte, Marlene, and Tom. And then on the YouTube membership side, we've got Bert, Hybrid, which is Dale, we've got Marie, Maya, we have Michael, Steve, Ford, Bello, Orkrad39, Littleback, Paul, Johnny, Stephen Cross, John Paul, Alistair Ware, who I met at the Cam Jam Festival a couple of weeks ago. Was it only last week? So hi Alistair. Cassie, we have Tinkering Rocks, Johnny, and of course we have Tom. So thank you so much for supporting this show. I can't tell you how much it means to me that you continue to do this on a monthly basis. It really means everything to me. And I think at this point in the video, I've got the little spinny logo, which tells me it's at this point in the video that YouTube will recommend a video over here from the over 400 video library that I have in my collection so far. It'll pick out a video that it thinks is most suited to you and that it thinks you will enjoy. So definitely binge that video. Let me know what you think in the comments below and check that out. And at this point in the video, if you're watching this on replay, I'll say thank you so much for watching and I shall see you next time. Bye for now.